The Earth just sent a signal. Scientists can't explain something just spoke. Not from the sky, not from deep space, but from beneath your feet. For decades, scientists have pointed their instruments outward, listening for signals from distant stars, scanning for whispers of alien civilizations, hunting for patterns in the cosmic static. But recently, something unexpected happened. The signal didn't come from above, it came from Earth itself. And what it said, no one fully understands. You live on a planet that is constantly moving, shifting, vibrating, breathing in ways too slow or too deep for human senses to detect. Beneath the ground you walk on, enormous plates grind against each other. Oceans press against continents. The molten mantle circulates like a planetary heartbeat. Normally, all of this motion blends into background noise. A low, chaotic rumble scientists know how to interpret. But this signal was different. It was precise, rhythmic, structured. It didn't behave like ordinary seismic activity. It didn't match earthquakes, volcanic tremors, or known geological patterns. Instruments across multiple continents detected it almost simultaneously, registering a strange pulse traveling through the planet's crust like a message encoded in stone. Researchers checked their equipment. Then they checked it again. The signal was real. To understand why that matters, you have to know how scientists listen to Earth. Around the world, thousands of ultra-sensitive seismometers sit silently in underground vaults and remote stations. These devices can detect vibrations smaller than the width of a hydrogen atom. They record everything. Earthquakes, landslides, glacier movement, ocean waves crashing against distant coastlines, even heavy trucks rumbling miles away. Most of the time, the data looks like static, random noise, natural chaos. But sometimes patterns appear, and when they do, scientists pay attention, because patterns means structure. Structure means a source, and a source means something is happening. The signal that stunned researchers wasn't loud, it wasn't destructive, it didn't shake buildings or wake sleeping cities. In fact, you wouldn't have felt it at all, but on monitoring screens it stood out instantly, a repeating pulse, steady, persistent. It travelled through the Earth at speeds consistent with deep seismic waves, waves that normally originate from powerful earthquakes, but there was no earthquake. No tectonic rupture, no volcanic eruption, nothing that should have produced such a clean, repeating vibration. It was as if the planet itself had tapped on the inside of its own shell. Scientists from multiple institutions began comparing notes. Teams in different countries confirmed they'd recorded the same pattern. Independent instruments, independent data, same signal. At first, many assumed it had to be an error, electrical interference, software glitches, calibration, drift. But the timestamps aligned perfectly. The waveform shapes matched. The frequency signature was identical. This wasn't noise. This was intentional behavior from a system that normally behaves randomly. And that's when confusion turned into fascination. Some experts reacted with cautious excitement, others with skepticism, a few with quiet concern. Because in science, the most unsettling discoveries aren't the loud disasters, they're the quiet anomalies. One geophysicist described the signal as too organized to be dismissed, but too unfamiliar to explain. Another said it resembled harmonic resonance, like a bell ringing deep inside the planet. But Earth isn't supposed to ring like a bell unless something strikes it. So what struck it? That question triggered a wave of competing theories. The first explanation was the simplest, a natural phenomenon we just don't fully understand yet. Earth is incredibly complex. Its interior contains layers of different densities, temperatures, and compositions. Sometimes energy can bounce between those layers and become trapped, creating resonant vibrations. Scientists have long known about something called Earth's hum, a constant background vibration caused by ocean waves interacting with the seafloor. Maybe this was a variation of that hum, a rare alignment of ocean pressure, atmospheric conditions, and crustal structure producing a temporary rhythmic pulse. Possible, but the data didn't quite fit. The signal's frequency was too clean, too stable. Natural processes usually fluctuate. This didn't. Another theory suggested unknown geological activity. Deep beneath the crust lies the mantle, a vast, slow-moving ocean of hot rock. Convection currents there drive plate tectonics, fueling earthquakes and volcanoes. Some researchers propose that an unusual shift in mantle flow might have generated the signal, like a massive underground ripple travelling through solid stone. But modelling showed that mantle movements happen far too slowly to produce such rapid, repeating pulses. Strike two. Then came a more exotic hypothesis: a deep Earth mechanical resonance. If a large enough disturbance occurs, say, a massive underwater landslide or sudden pressure release, it can set part of the planet vibrating like a tuning fork. In rare cases, these vibrations can travel astonishing distances with very little loss of energy. There are historical examples. In 2018, seismometers worldwide recorded a mysterious global wave that lasted over 20 minutes and had no clear earthquake source. It baffled scientists for months before they linked it to volcanic activity near the Indian Ocean. So maybe this new signal was another rare resonance event, except there was no geological disturbance large enough to trigger it. Nothing broke, nothing collapsed, nothing erupted, yet the signal happened anyway. That's when researchers considered something stranger. Interference from outside Earth. Our planet is constantly bombarded by solar radiation, magnetic storms, and charged particles streaming from the sun. These can interact with Earth's magnetic field, producing measurable electromagnetic pulses and even low-frequency sounds known as chorus waves in near-Earth space. Could a burst of solar activity have coupled with Earth's crust and produced a seismic signal? Space weather data was checked. Solar conditions were calm. No flares, no storms, no spikes. The sun was quiet. Earth wasn't. By now, curiosity had turned into urgency, because the signal didn't just appear once. It repeated, not continuously, not predictably, but enough times that scientists could confirm a pattern. Each occurrence carried the same frequency signature, like a fingerprint, and each time it appeared, it lasted just long enough to be unmistakable, then vanished back into silence. Something was switching on, sending a pulse, switching off. No natural process behaves quite like that. Researchers began mapping the signal's origin point by comparing arrival times at different sensors. This is how earthquakes are located. The difference in wave arrival times reveals where the disturbance began. The triangulation results pointed somewhere unexpected. Not a fault line, not a volcano, not an ocean trench, but a region of ancient, stable crust, geologically quiet for millions of years. That detail rattled experts. Stable regions aren't supposed to produce mysterious pulses. They're the calmest parts of the planet, the geological equivalent of silence. And yet, that's where the signal came from. Why does this matter to you? Because signals mean processes, and processes inside Earth can affect everything on its surface. Earthquakes, magnetic field shifts, volcanic eruptions, even climate patterns over long timescales. Most of the time, Earth's internal systems operate in balance. but unexplained signals suggest something might be changing deep below. Not necessarily dangerous, but not fully understood. And what scientists don't understand, and they can't predict. As researchers dug deeper into the data, they noticed something unsettling. The intervals between pulses weren't random, they were shortening. Not dramatically, not in a way that would alarm the public, but enough to catch the attention of statisticians analysing the sequence. The signals seemed to be occurring slightly more often over time. That raised a chilling possibility. What if the source wasn't a one-time event, but an ongoing process building towards something larger? Among all the theories, one stood out as the most unsettling, not because it was likely, but because it was scientifically plausible. A slow, structural shift in Earth's deep interior. Far below the crust, depths humans will never reach, the boundary between the mantle and the core is a dynamic region of extreme pressure and heat. Some geophysicists believe massive structures, sometimes called mantle blobs or ultra-low velocity zones, exist there, moving gradually over millions of years. If one of those structures were changing shape or position, it could theoretically generate periodic seismic pulses as stress redistributed through the planet's layers. In other words, the signal could be the sound of Earth adjusting itself from the inside out, not an explosion, not an earthquake, a planetary recalibration. Then came the twist. A new analysis compared the signal's frequency to known physical constants related to Earth's structure, its diameter, density distribution, and elastic properties. Researchers discovered something astonishing. The pulse frequency closely matched one of Earth's predicted natural resonance modes, the theoretical vibration Earth would produce if struck with the right force in the right place. It was as if the planet had briefly vibrated in its own natural tone, like a bell ringing its true note. But no one knows what struck it. Discovery changed everything, because it suggested the signal wasn't random noise or mechanical friction. It was a resonance event, and resonance requires energy input. Something must excite the system. Scientists are now searching for that trigger. Some suspect hidden geological movement too subtle for current instruments. Others think a previously unknown coupling between ocean pressure and crustal structure might be responsible. A few believe the answer lies deeper still in processes we don't yet have the technology to observe. For now, the truth remains just out of reach. Here's what makes this story unforgettable. You're standing on a world that might occasionally send signals from its deepest layers, and we're only just beginning to notice. For most of human history, we thought Earth was silent beneath us. Solid. Still, predictable. We were wrong. It murmurs, it vibrates. Sometimes it speaks. And recently it said something that scientists are still trying to translate. The instruments are still listening every second, every hour, every day, waiting for the next pulse, waiting for the next clue. Because somewhere inside this planet, far below cities, oceans, and continents, something is moving in a way no one fully understands yet. And the next time Earth sends a signal, we might finally learn what it's trying to tell us.